Hello and welcome to this video. In this video, we are going to discuss or compare GCP BigQuery versus open source Apache Spark. There has been a long going discussion on which tool to use or a comparison between the capabilities of BigQuery versus Apache Spark. I'll try to give a conclusion at the end of the video, so stick with me. Both of the tools that we are discussing are a prominent tool in the big data world. I'm sure you would have come across both in the recent times. Let us try to first get a definition of both of these tools. BigQuery is a completely serverless and cost-effective enterprise data warehouse, which is offered by Google Cloud or GCP. It has built-in capabilities to do analytics and any kind of BI work. Not just that, it also has an extended capability to do machine learning queries or running machine learning models on it also. Apache Spark, or what we call as an open source Apache Spark, is a unified analytics engine for large scale data processing. It is completely open source and you can install this in any of your servers in your organization and start using Apache Spark. The underlying of Apache Spark is written using Scala. And when we install this, because it is an open source, and when we install this, we will have to set this up by ourselves, and you would need some kind of data platform or data engineers who have the knowledge of this setup. Both these tools say that they can perform large scale data processing. So what is the difference exactly, and where are we heading in the future? Well, one clear difference is Apache Spark is open source, whereas BigQuery comes as a part of licensing with GCP. The performance comparison of Spark and BigQuery is explained very well in one of the blocks, wherein we are processing a 75 GB of data stored using Spark, which comes in GCP also in a tool called as Dataproc, and in BigQuery SQL. This graph that you see is actually from a Medium blog called as comparing BigQuery performance and Spark using Dataproc. You can clearly see that there is a very big difference in the time taken for the processing. There is some kind of processing time used that is around 400 seconds, wherein BigQuery SQL can perform this in a much efficient way. So what exactly is BigQuery doing to run this faster? Well, we don't really know because this is completely a serverless tool as we discussed. And all of the underlying infrastructure is maintained by Google, and all you have to do is just run a query from BigQuery console. You have very less control over the infrastructure. If the queries are running faster, why would we complain, right? This graph clearly indicates an upper hand for BigQuery. And that's the reason why we are making this video, because BigQuery is constantly getting adapted in a very rapid pace in many of the organizations. The reason is because of its capability to process data much faster and its extended capability to perform other tasks in GCP in comparison to Spark. So what's a one-on-one comparison between BigQuery and Spark? Let us try to understand this. A one-on-one comparison looks something like this. Let us go through each one of them. BigQuery is completely serverless. We don't have access to any of the infrastructure, wherein Apache Spark needs a data platform setup. When you are using BigQuery, you can query and process the data both using the same tool. So what is query? It is analytical query. If you want to do this using Apache Spark, it is not technically possible. You will have to adapt some other analytical tool like Hive to do the same. Apache Spark is used mostly for data processing, which it does very well, of course. But BigQuery, you can use it to do analytics, like running some SQLs on top of the data that has been processed. And also you can use it to process the data, like running an ETL, and use BigQuery as your computation engine. There is no infra cost. You pay basically for the amount of data you process. If you process 10 GB of data, you pay for 10 GB of data. Wherein with respect to Apache Spark, because it is open source, you don't really pay for the tool, but you will have to pay for the infrastructure. And as you scale the Apache Spark in your organization in the future, the cost of infrastructure increases, which will have to be addressed at some point of time. With this, you will also have to build some kind of automation, right? So let us say you have 10 Apache Spark nodes. You have 10 Apache Spark nodes. This will not be enough. Let us say in 2025, you would need 30. So you will have to kind of do this maintenance on this cluster. The next point is BigQuery has an ML module which you can use for data science, and the same is true for Spark also. GCP license is required for accessing BigQuery, but with BigQuery, when you get a GCP license, with BigQuery, you get other tools also that is related to big data, like Vertex AI, other tools. Wherein in Apache Spark, you don't really need any license, but Apache Spark itself cannot do anything. It is a pure computation engine, right? So you will have to figure out some kind of storage structure. You will have to find some kind of storage mechanism for it, maybe S3 or GCP storage or HDFS, which is Hadoop file system. So in other words, Apache Spark is not a standalone tool that can be used to do multiple things. Yes, it can do large data processing, but it would require other big data tools to also serve it or help it. With this clear differentiation, let us try to understand what is going to happen in the future. The big data world is evolving, which means in the future, what is expected out of a big data project or a big data engineer? Efficiently solve a use case for a company. This use case can be finding a user analysis. It can be finding why a particular sales dropped, anything. To find this answer as fast as possible, you would need to have a good automation and good setup in place. Hence, the way I see the future of big data in comparison of BigQuery in Apache Spark is what I have written in this conclusion. This is my personal thought, and I might be wrong, of course. I believe that all new big data projects that are going to start will prefer to use a GCP BigQuery in comparison to Apache Spark. Let us say we have a small startup of 10 folks. Now, these folks have a lot to do, right? And if these people have to do some data analysis, they will not just set up Apache Spark. It requires a lot of effort to set up an Apache Spark in a compute instance. Rather, I believe that they will prefer to use the GCP BigQuery. Existing companies or organizations that are using big Spark cluster might start migrating to serverless versions soon. Clearly, very big organizations, example like Walmart or Mercedes-Benz or any other organization, they would have adapted a very big Spark cluster, which means they have a lot of servers, maintenance of it, etc., etc. This is not something that is sustainable when you have an alternative option already present, and they will start exploring this in the future. Apache Spark shall remain the fundamental framework for distributed big data processing, but it will be wrapped with other tools, exactly what BigQuery is doing or AWS Athena is doing or Dataproc will do in the future. The conclusion that I have regarding Apache Spark for, let's say, existing big data engineers is start focusing on alternative tools because it is getting adapted, and I believe that within 2-3 years, Apache Spark might not be a tool for big data processing in terms of a standalone tool. Well, for new big data engineers, I would say that Apache Spark still is a fundamental concept for distributed data processing. Hence, go through it, but don't just have that as your tool in your resume or your projects. Try to explore GCP BigQuery, GCP BigQuery stored procedures, Dataproc, AWS EMR, AWS Athena, etc., which focuses on the serverless concept. So the key here is serverless. Anything that is serverless in the big data world will be appreciated in the future, and that is what I believe. This is the comparison between BigQuery versus Apache Spark. I hope you like this video. If you do, please click on the like button and do subscribe for the channel for more content around big data. Thank you.